Yeah, hi everyone. So my topic is about sustainable home labs. So anyone out here has heard about home labs, like know what it is? Yeah, so quite a few amount of people. So yeah, I think yeah. So the agenda is a bit of uh, a misdirection. So I don't have everything in the slides. It's a very short presentation. But yeah, so what exactly is like home labs, right? Uh, Okay, I can do this after that. But yeah. So yeah, the home labs are basically something that you have at your home, which will be running things like testing environments or something like that that you would prefer to not do at work, right? So some examples of home labs are like your own Kubernetes clusters at home, right? So this talk is mainly for people who do home lab stuff, not for people who use home labs as businesses, because that's a whole different requirement and you cannot probably scale in that. So yeah. Can you go back? So yeah, about me, I am a customer success engineer at a company called Sora.io. We run things like service meshes and gateway APIs and like edge APIs in the cloud. We are mostly Kubernetes focused, so we have a whole service mesh and like gateway products. So yeah. If you want, you can like connect with me using the QR code. So that's yeah. Yeah, so these are some examples of like home labs. Basically, it's your own test bed. So you can run things like maybe softwares you wouldn't run in your production environment. Things like for example, I run like a whole Kubernetes cluster at home, and I run it on a mini PC, it's like a PC that you can keep on the table. But there are cheaper alternatives like Raspberry Pis. Then there is this. So the one difference that today people like look for is like architectures or CPU architectures that run more efficiently. So there's ARM, and like I have a Raspberry Pi, so that runs on ARM. I also have recently got into the RISC-V CPU architecture. So it's still quite new, but it's more efficient than the ARM cores. So currently ARM is in market. Probably people have heard of Graviton servers and all these things. So yeah, but yeah, these are like some examples of a home lab. Like for example, NAS servers were like I think pretty cool back in 2000s and all. Like where people used to just download all the media and like host it on their servers and then torrent it out. So yeah, they still exist, but people just now use them for personal stuff maybe because storage is quite cheap. So you can have like 8 TB or 60 TB servers at your home and just run it. But electricity costs have also gone high, so nobody wants to do that anymore. Yeah. So yeah, so there is a difference between traditional servers and like your home labs, right? So traditional servers, they usually take a lot of power. So you'll have like an entire rack blade server, which is like a tower, which has, I think, 7, 8 servers in a rack. And they usually cover at least half of this stage of one side of it. And people do run that. Like, for example, I know folks in the US who have like little racks of servers in their basement, and they just run it like 24/7. So it's also used as a heater in their house because the amount of heat that it generates is a lot. So they don't require most of the heating equipment in winter season. They just sleep on the floor and use that. But yeah, but I also know that people in India have started doing this, where they reach out to people who like have home labs or who own data centers, and they just buy these servers of them, the rack servers. But with that, what happens is that you get a server which is like going to consume at least 5,000 rupees per month, and that's just one single server. And if people run that like 24/7, then the cost increases off. Uh, on the other hand, there are something called as like mini PCs or Intel NUCs, if anyone has heard about those. They are usually palm-sized. They have the max capacity today is 64 GB of RAM, which I feel is like more than enough for one computer to have. And then you can just stack them up. They are way cheaper than like your traditional servers, even though they don't come with like, extremely high CPUs, or they don't have like, 80 cores in them. But I don't think so anyone running a home lab requires 80 cores in today's time at least. They are like quite idle. Like I have two at home and they just sit on my desk. They literally disturb no one at home and they're like extremely silent. My mechanical keyboard is much louder than those PCs. So a good like comparison. Yeah, so this right. So older hardware means more electricity cost because they are not optimized for today's time. At least they run hot, so you require to cool them up, and that also requires more additional like electricity cost and all. So yeah, so I did a thing that like most youngsters do today. I went on Twitter and I asked people online. So so yeah, so people on Twitter they responded saying that see everyone's suggesting like they want us to use cheaper and green energy, right? So nowadays products also have this green energy certification that they come with. So those computers are meant to use just green energy. Now I don't know if that's a gimmick or that's actual something, but it does come with certifications these days. So yeah, so these are all people who have been in the industry for a long time, and they also told me the same thing that do not use rack servers anymore. People who have rack servers, they either send them for like to the junkyard, or they just power them off. But yeah, so yeah, I asked multiple people, so they told me like some switched from traditional servers to things like mini PCs, Raspberry Pis. There are Odroids. There is this company called Odroid H3, or there is Turing Pi. Then there is many Pis have come out like since the Raspberry Pi came out. There is things like banana pie and like all flavors of fruit, so you can pick from any one that you want. But yeah, so most of the people just spoke about one thing, and that is power usage compared to the electricity cost, right? A simple Raspberry Pi does not add a lot of energy cost to your home, but it could give you like an entire Kubernetes cluster. Like a single node Kubernetes cluster could run on a Raspberry Pi that just sits at your desk. It just requires a small fan, as like this small is the fan that I use for the Raspberry Pi. So it's much power efficient, much space efficient. You don't have to sit and uh, have a whole rack for it. Like your entire room isn't occupied by a server. So yeah. So yeah, people also switch to something called as think centers. So these are Lenovo mini PCs. They were quite popular during like when I was working like 3 4 years ago. They were these thin client PCs that you have your data stored in a central server, and these PCs you just connect to that server and then pull data from it. So you could do things like in Windows roaming the so any PC you'd go and log in, you'd get your own files basically. So as you can see, like there are like 16 cores and 32 threads in that. Like it's a Proxmox lab, so it's like a virtualization lab that he built. And I think he shared a photo also at the end. So yeah, so this is his lab. So this is not something that I think Indian people like would do in their house. We have a lot of space issues. So foreign people, they have enough space to keep things. So they have this. He had shared this photo with me, saying that okay, this is his Synology NAS. This is where all his storage is, and it's quite compact. So this is like a small table. Like I know that it's not visible, but that's just a laptop screen. That's laptop for the size of a table. And this is, I guess, a switch. And these are the four Lenovo PCs and a Dell mini PC that he has. So that's the smallest lab I think I have seen. Mine is much smaller, but yeah, depends on your needs. Ultimately, it depends on what you require. But yeah, that's it for Sustainable Home Labs. So it's a quite short presentation, but yeah. Any questions, anything? Uh, yeah. Yeah. Yeah, so mini PCs are just your normal PCs. So if you run Windows and if VMware works on EXI host, I'm not sure if EXI requires Windows, but it does not. Right? So it's a normal PC. Like if you can flash it maybe to a normal PC, you can flash it to a mini PC. Yeah, yeah. So, yeah, so like you said, right? So the thing is, they don't really have that much limits these days. Like the ones that are like the max I have seen, like Intel goes to i9, and those are like 12 cores, 16 threads. So I don't think so. Like there is a lot of constraint with CPU also these days. Yeah, yeah, they do. The Intel NUC series has been discontinued, but you do have like Dell, Lenovo that make these mini PCs. Yeah, yeah, the Asus N95 series that is there, that is the ongoing ones currently. And yeah, okay, so yeah, that's a very this. Yeah, mini PCs yeah, yeah, yeah. So I also don't keep my lab on like all the time because I don't need it to be on. So these mini PCs are quite good that way. Raspberry Pi. It depends again. Like it's yeah. So it depends on your use case basically. So you can do things like stack Raspberry Pis, like 7, 8 of them, and have like this small cluster, and it could do a lot of things. Like you could do multi-cluster stuff. You could do uh, availability stuff with that. Okay. Thank you.